Okay, let us start today's lecture. In next 30 minutes, we are going to cover these programs. Sum of array elements, simple program which will take input for integer array and print its sum. Second, same program using pointer. We are not allocating the memory statically, we are using pointer and running the program. Next is structure. Yesterday we have covered structure. So we will see one more program, array of structures. Already I have created the program. As I told you, these are the program that was already present with me. So I am not wasting the time to create the program. So array of structures. Next is 2D array. 1D array, 2D array, 3D array. We will learn the complexity in general. Next is array of structure for printing mark sheet of students. Okay. Next is linked list. How to create linked list, how to print linked list, and you are expected to create the same linked list for n elements. I will tell you how to create for 4 elements. You are expected to extend the same program for n elements. Okay. So let us cover the program one by one. First is sum of array. You can check. You can see here. This is the program for sum of array. So here include stdio.h, stdio.h. Here the variable array name is A100. There are 100 numbers. If integer occupies 2 bytes, so how many bytes are occupied? 100 into 2, 200 bytes are reserved. Okay. I comma j, sum equal to 0. So sum is the variable which saves the sum of all the elements in the array, and this is the n is the size of array. Okay. So first ask the user what is the size of array. Enter array size, scanf % and n. Now we are saving the size of array in variable of name n. Clear? Next is enter array elements. Using for loop, we are taking the elements input in the array. Okay, for I equal to 0 to n. Enter array elements, scanf % and a of I. Now I am printing their sum. Again I will use the for loop. For I equal to 0, I less than n, plus I. Sum equal to sum plus a of I, and immediately I am printing the sum. Okay. Immediately I am printing the sum. You can see here array elements, position values, I, a of I, and their sum. Clear? So let us run the code. So my program will be sum array.cpp /a.out. Enter array size. Okay. So array size is 5 elements. Enter array elements. Suppose 1 2, 1 4, 1 6, 1 8 to 80. 5 elements are there. Okay. You can check here the output. Array elements are 12, 14, 16, 18, 20. Now sum is initially 0, 0 plus 12 is 12. Okay, sum is 12. 12 plus 14 is 26. 26 or 26 plus 16, 42, 42 plus 18, okay, 60, 60 plus 420, 80. So this is a simple program to print sum of elements in the array. Clear? Now my question to you, how many times this for loop execute. This program execute how many times? This for loop execute how many times? N times. Okay, this for loop executes n times. So n plus n, 2n. N plus n, 2n. So complexity of this program is big O of n. What is the complexity of the program? Big O of n. We are removing that number. So this program executes n times. Okay, clear order? Okay, good. Next is same program using pointer. Same program. So this is the second program using pointer. So what I have done now, int star a, stop a, int star a, ij sum equal to 0 n. Enter array size, scan a percent a and n. And here, as I am using malloc function, memory allocate. Malloc stands for memory allocate. For that I need stdlib.h file, standard library, which define malloc function. Okay. So here in the previous code I have written int a of 100 and I have taken input for how many elements? 6 elements. How many elements? 6 elements. So if integer occupies 2 bytes, and there are 100 elements, so for this I need 200 bytes of memory. Okay, but actually I have taken only 6 number, so 2 into 6 equal to 12 bytes are only used, and we have wasted how many bytes? 188 byte. Clear? We have wasted. So this is drawback of static memory. That's why what I am doing now, I am taking the pointer int star a and allocate memory for only the elements. How many elements? N elements. So syntax is a equal to int star malloc n into size of it. Okay. Here I am doing typecasting int star malloc memory allocate. What is here? Enter size of array. We are storing in n variable. So malloc n into size of int. And here enter add element, same program is here. Rest of the program is same. Baaki the program same hai. Enter add elements, carry percent a and a of I and print a of I. That's it. So what we are learning here? We have learned only 2 syntax. Stop and declare int a of 200, int star a, note down this thing, int star a and a equal to int star malloc n into size of int. That's it. So in this code we have learned how to allocate memory using pointer for array. Clear? Yes or no? Suppose this array is of 2 dimensional, a of 3 by 3. A of, then how to do the program? Int double star a. If studio array, int double star a, first step, and when we allocate the memory, here size of, here row, number of row are 3, number of columns are 3 into size of it. Clear? Int star star. If we take number of row and column in variable m and n, if we take number of row and column in m and n, that this should be m into n into size of it. Clear? Yes? Same program I can do for 2D array. ठीक है. Now let us run the code. Uh, Enter array size, all elements, array elements 11, 12, 13, 14, 15. Okay, now you can see the same output. Okay, clear? So here in this program, what did we learn? How to declare the array dynamically using pointers. Okay, clear? Good. Now next program is yes, we can create. We can use, there is a statement of name free. Okay, and here that pointer. We allocate the memory using malloc. In the same code, when the code get execute, when code execution get finished, then we can free the space immediately in the program. And what if I don't use that free? When I close the program, as program close will always, it is part of operating system. It is part of operating system. You will learn in the third year. Fragmentation, memory allocation, different memory allocation techniques are there. So at that time memory gets free. Clear? So but here if I use free, in the program itself, whatever memory is being occupied by the RAM by the program get freed. So free is the statement which frees the memory that has been occupied by the pointer. Clear? Okay. Next program is 2D array. Okay, tell me how many times the statement get executed. Just see the code. 4, 5, 6 किती वेळेस होते? Array declared. Okay. For I equal to 1 to 3, j equal to 1 to 3. Value of I and j are I, comma j. Okay. Now tell me what is the output of this code? काय याचं आउटपुट? 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. So how many times loop got executed? 9 times. How do I get 9? Here it's less than 3. 1 2 3 1 2 3 9. So what is the completion of the program? Big of 3 into 3. Okay, this 3 into 3. Suppose I replace 3 by m row, n columns. M row and n columns. And here I ask, enter number of rows, can a person be and m. Enter number of columns, can a person be and n. For I equal to 1, I less than m plus plus I. For j equal to 1, j less than n plus plus j. Print ij. So what is the complexity of the program? m into, clear है? m into, समझ ले बेटा? Any doubts? Yes or no? Clear है? Okay. In the previous program, here this loop execute how many times? N times. Suppose I write here n equal to n, but what will happen? Now how many times loop get executed? किती वेळेस होईल लूप? See here the mathematics. What is mathematics? Suppose here equal to 8. What is statement? For I equal to 1, I less than n, s plus I. Here I written n equal to n divided by 2. Okay. So when I is 1, I comma n comma n equal to n by 2. I is 1, here is 8. Now n equal to n by 2. What happens? N equal to 4. Now plus plus I becomes I becomes 2. What is the condition? I should be less than n. Here 1 less than n, yes. Now tell me 2 less than n is now 4. True? Yes. Loop get execute. I becomes 3. Now what happened? Here n becomes 4. N becomes 4. Now n equal to n by 4. 4 by 2, 2. Here it should be I less than equal to n. Equal to. Okay? Now here n becomes n किती होते? किती होते? लूप गेट ब्रेक 3 less than equal to 2. Loop get break. Now take n equal. So here how many times it got executed? Big O of log n. Log n म्हणजे काय? log n म्हणजे काय? लक्षात द्या. 2 raised power 3 equal to 8. So log to the base, log 8 to the base 2 is 3. 2 raised power 4 equal to 16. Now log 60 equal to, here we are assuming base 2, not 10. Here base is 2. म्हणजे काय? काय होईल तर 4. So whenever I use n equal to n by 2, it is log n. Because we always divide by 2. म्हणजे काय होईल? पहिला 8 होतं, नंतर 4 2 1. 16 8 4 2 1. Suppose n equal to 32. What will happen? Suppose this is 32. What will happen? Yes, suppose this is 32. काय होईल सांगा? How many times this loop will execute? 5 times. 5 times. 32 16 8 4 2. Loop get break. Finish. 64 log n 6 times. So whenever we use n equal to n by 2, log n, remember. So what is the complexity of this program now? Log n. Clear? So this is the answer of this question. If I make it n equal to n by 2, n equal to n by 2, okay, and complexity of this loop is log n, and this loop is n plus log n. What is complexity now? N. Always take the higher side. What is total side? Here n plus log n is n. Always take the higher number. So the complexity of this program is n. Clear? Where we do the computation, it will be in log n, remember. When we do the computation, it is log n. So complexity of this program is not n, it's log n. Computation is there. This is used for storage. But whenever we are doing the computation means we are doing some operations. At that time, whatever is the logic, as per the logic, complexity gets modified. Otherwise, what is the complexity of binary search? Log n. It should have been n otherwise. Clear? So always take the complexity when we do the computation. Clear? When we do the binary search, we use the for loop to take the input for n numbers. We do the binary search. The complexity is log n. So remember, the complexity of the program is log n. So what we have to consider, not to take input and output, we have to consider computations. Clear है? चला ठीक है. Now next is linked list basics. Okay, this program I have asked you.